Stoichiometry example problem number 2. Here we go. What's happening here? Well, we have this stuff, H2CO3, called carbonic acid. Hey, that's the stuff. If you enjoy a can of pop, that's the fizzy stuff. And it breaks down to make water and CO2. All right. And the question that we're faced with is, how many molecules of CO2, how many individual molecules, how many CO2s are out there? How many of those can you make from 1.25 moles of carbonic acid? We're starting with moles when I get to molecules. Well, with any stoichiometry problem, you have to have a balanced chemical equation. Let's take a look at that. So this molecule has 2 hydrogens and 2 hydrogens. Those balance. 1 carbon, okay. 3 oxygens. I see 1 oxygen, but wait, there's 2 more. 1, 2, 3 total oxygens. This thing's already balanced. It's all 1-to-1 ratios. If you have 1 mole of carbonic acid, you make 1 mole of water and 1 mole of CO2. So pretty straightforward there. Let's dive into the math part. Here goes. We have 1.25 moles of carbonic acid to start. All right. Yeah. 1.25 moles of H2CO3. Okay, that's good. Well, we're going to go for molecules in the end, but if we have a balanced equation up here, it's the mole ratio. 1 mole of this makes 1 mole of that. We can always convert from moles of CO2 into molecules with Avogadro's number. So keep that in our back pockets and get right to it. Let's do the mole ratio. Okay, well, different color marker. Here we go. Beep. Here's our mole ratio. For 1 mole of H2CO3, I'm going to make 1 mole of CO2. H2CO3, 1 mole CO2. And yeah, I know dividing by 1 and multiplying by 1 give you the same number, but you guys know in chemistry class it's important to show your work to your fellow chemists so they know where the numbers came from. That's why I put all those units on those calculations. And right now the moles of carbonic acid, it is canceled, and we have moles of carbon dioxide, but we don't want moles, we want molecules. We need 1 more conversion factor. Let's break out the blue marker for our next conversion factor. If we had 1 mole of carbon dioxide, or 1 mole of anything, well, it's 1 mole of CO2, you should know that there are 6.02 times 10 to the 23rd of those things. In this case, molecules. All right, the moles of CO2 cancel right out. And here we go, 1.25 times 1 divided by 1. All the ones, hey, they're not going to change anything. So it's this times that. The only units left are molecules of CO2. So once again, I'll race you there with the calculations. Maybe you already had this done. You're just double checking it to see if you got it right. Either way, here we are. Clear. 1.25 times 6.02 times 10 to the 23rd. Aha! I get 7.525 times 10 to the 23rd. And crud, we only have 3 sig figs. So we have to round, but which way to round? It's right on the 5. Round up, I say. So here we go. 7.53 times 10 to the 23rd molecules of CO2. Come on, S. There we are. And hey, if you type this one in and it gets wrong on the computer program, try rounding down, 7.52. But we have to keep to those 3 sig figs. And there we are, your second example problem. The key thing is to show all of your work and make sure the units cancel out. And if you do that, you're on the right track. Thank you.